Choose the right chart starts with one simple rule. Time usually belongs on the horizontal axis, so line and area charts show change clearly. By the end, you'll know when to use line charts, when to use area charts, and when to avoid pie charts. Start with the axis choice, because that decision shapes how the rest of the chart reads. When time is the variable that moves forward and the outcome changes in response, placing time on the horizontal axis lets the viewer read the sequence from left to right without friction. That convention matters in both business reporting and statistical analysis. If you put time on the vertical axis, you force the eye to work against the natural order of events, and the pattern becomes harder to track. The question to ask is simple. Which variable is the timeline, and which variable is the response? So the rule is not decorative. Time usually goes on X because it organizes observation into order, and order is what lets trends, cycles, and turning points become visible. If you had monthly revenue, daily temperature, or quarterly defects, which axis would help you see change most clearly? Choose time on the horizontal axis when you want the reader to follow change as a sequence. That makes the chart easier to interpret, and it preserves the logic of how the data happened. Now that time is on the horizontal axis, the next question is what shape best shows continuous change? A line chart connects ordered observations, so your eye can follow trend without stopping at each point, as if it were isolated. Use it when the values are measured across time, and the goal is to see direction, seasonality, or rate of change. Rising slopes show acceleration in the response. Flatter segments show stability. Repeated up and down movement can reveal periodic behavior. If the data are categorical rather than continuous, a line can imply a continuity that is not really there. So the best explanation for a line chart is not just that it is common, but that it matches the structure of time-ordered numeric data. For a monthly series, what would you predict a steep slope is telling you? Building on the line chart, area charts keep the same time order, but add filled space under the line. That fill makes cumulative magnitude or total volume feel more prominent, so the chart works well when the total amount is part of the message. This is useful when you want to emphasize how much has accumulated over time, not only where the line is going. But stacking can complicate the reading, because the upper series depends on everything beneath it. So ask whether you need total volume or whether you need each component to stay visually separable. If the categories overlap too much, the fill can hide more than it reveals. In that case, the chart still shows change, but it may no longer support precise comparison. The best explanation for an area chart is that it highlights magnitude across time, provided the layering does not blur the data. Now we move from time to categories. When the values belong to discrete groups, a bar chart is usually the clearest choice, because each bar starts from the same baseline, and length becomes the direct cue for comparison. That shared baseline makes ranking fast. You can compare products, regions, departments, or customer segments without asking the viewer to estimate angles or infer totals from stacked shapes. The main question is whether the categories are separate enough that each bar stands for one distinct group. If the categories have an order that matters, you can sort the bars to sharpen the comparison. If they do not, the order can still be chosen to support the story. So the rule is, use bars when you want magnitude across groups, not change across time. Which chart would you choose for sales by region? Once you have a single numeric variable, the question changes again. You are no longer comparing named groups or tracking time. You are asking how the values are distributed across the sample, and a histogram is built for that task. A histogram groups values into bins, then counts how many observations fall in each interval. That binning reveals shape, spread, skewness, and whether the data may have more than one peak. The exact bin choice matters because too few bins hide structure and too many bins create noise. So, a histogram is not just a pile of bars. It is a way to inspect the pattern of one quantitative variable as a whole. If you were looking at customer order sizes or exam scores, what would you expect to learn first? The average or the shape of the full distribution? After you see the whole distribution, the next step is often comparison across groups. Box plots compress each group into median, quartiles, spread, and outliers, so you can compare centers and variability without reading every individual point. The box marks the middle 50% of the data, and the line inside shows the median. Whiskers and outliers help you see how far the values extend and whether unusual cases are present. This is especially helpful when you need a robust summary that is less sensitive to extreme values. Choose a box plot when the question is, how do these groups differ in typical level and spread? Not, what is every observation doing? If two departments have similar medians but different box heights, what does that tell you about variability? Now we shift to two quantitative variables at once. A scatter plot places one numeric variable on each axis, and each point becomes one paired observation, so you can inspect how the variables move together. This is the chart for correlation patterns, clusters, nonlinear structure, and anomalies. If the cloud slopes upward, the variables tend to rise together. If it slopes downward, one rises as the other falls. If the points curve, a straight line summary may miss the real pattern. The useful habit is to ask what the point cloud is doing before you fit anything. You can see separated groups, a funnel shape, or a few points far from the rest. Those features often matter more than a single coefficient. If you had ad spend and revenue, what relationship would you expect to inspect first? So, the scatter plot is not about decoration. It is about reading paired data directly before simplifying it. When the relationship is weak, nonlinear, or interrupted by clusters, the raw pattern is often the best evidence you have. Sometimes the data are not best shown as points or bars at all. When you need to display magnitude across two dimensions, a heat map uses color intensity to encode value inside a grid, and the pattern becomes visible across the matrix. This is especially useful for dense tables, correlation matrices, schedule patterns, or any layout where many cells must be read at once. The viewer does not trace a line or compare bar lengths. Instead, they scan color to find concentration, symmetry, or repeated structure. The key decision is whether the color scale is easy to interpret and consistent across the full display. If the palette is confusing or the range is compressed, the chart can hide the very differences it is meant to show. So the heat map answers a specific question. Where is the intensity highest and where is it lowest? Now we can put the selection rule together. The best chart is the one that matches the data type, the question you are asking, and the level of precision your audience needs. If those three do not align, the chart may be technically valid, but analytically weak. For time-ordered continuous data, lines and area charts help you read change. For discrete categories, bars support comparison. For one numeric variable, histograms and box plots answer different questions about distribution and spread. For two numeric variables, scatter plots show relationship, and heat maps help when a matrix is too dense for point-by-point reading. So the practical test is not which chart looks polished. It is what structure does the data have, and what decision must the viewer make? If you choose by that rule, you reduce distortion and increase clarity. Which chart would you choose when you need the most precise answer, and why? Fit comes first. Data type, question, precision. When those three line up, the chart supports interpretation instead of competing with it.